DIS is the leader in seismic isolation, with over 250 building and bridge projects completed to date. As you see here, earthquakes caused considerable destruction to not only the structure, but also its contents. The shake table demonstration shows a building model that is not isolated. There is considerable damage to the contents. The same building is now isolated from the shake table and experiences much lower acceleration. Its contents are unaffected by the ground motion beneath it. The lead rubber bearing is made up of alternating layers of rubber and steel that provide high axial stiffness combined with low lateral stiffness. The lead core provides energy dissipation to absorb seismic motions. The isolators are typically installed under each column in a building and on the tops of piers in bridges. DIS has isolated several prominent historic structures. The most recent retrofit was the Utah State Capitol building with 273 isolators, as large as 45 inches in diameter, weighing 6,000 pounds each. Hospitals are excellent isolation candidates. An isolated hospital will be operational immediately after an earthquake because its contents will be undamaged. This is critical to saving lives after a disastrous earthquake strikes. The Xintian Hospital in Taiwan is currently the world's largest isolated building, with 1.3 million square feet of floor space. It will be surpassed in 2007 by another hospital in Taiwan with 1.7 million square feet of floor space also protected by DIS isolators. This video footage is a prototype test for the Xintian Hospital. The 1.3-meter diameter bearing is displaced to 1 meter while supporting a load of 2,000 tons. The extreme performance of this bearing is achieved using advanced rubber formulations developed by DIS and by the incorporation of molding and processing techniques not normally used by the general rubber industry. Emergency centers and fire stations are popular applications of base isolation. The purpose of the emergency center is to be fully operational after an earthquake, to enable recovery efforts to commence immediately after a disaster. The building will allow city, state, and federal agencies to coordinate from one location. Condominiums are often isolated. The demand for them has been driven by their occupants who wish to live in safer, high-performance structures. Buildings that generate high revenues, such as computer chip plants, or that house essential equipment, such as found in the telecommunications industry, warrant better protection than that provided by conventional design. Museums that house not only valuable but irreplaceable artifacts of our culture also deserve the utmost preservation that can be engineered. The Coronado Bridge in San Diego was designed to withstand a rupture in the fault that it crosses over. The incorporation of viscous dampers and seismic isolators will enable the bridge to withstand that event should it occur. The testing shown here was conducted at the University of California at San Diego. The test machine was built by Caltrans in order to test full-size bridge bearings at actual speeds. The tests replicate the actual conditions during an earthquake. The isolation bearing shown is 41.5 inches in diameter and has an 11-inch diameter lead core in the center. The time to complete each cycle of testing is 2 seconds. This test machine has proven to be a real asset to our engineering community. It has enabled us to better understand the performance of structures and seismic devices under real earthquake conditions. Isolation provided cost savings for the JFK Light Rail project. The reduction in forces enabled the foundations to be smaller and to cost less. More importantly, the smaller foundations eliminated the need to relocate many of the underground services and utilities, providing further cost savings. You may contact us for further information. We would be pleased to share the wealth of information and expertise we have acquired over numerous projects.